Unlock the concepts of AP Physics, one concept at a time. So hey guys, welcome back to the channel. In today's video, we'll be going to talk about ideal gas. Like what is an ideal gas? What makes it different from other gases? Is there any gas which is considered as an ideal gas? We'll answer all these questions in this video, and to get more idea about it, just stay tuned. Welcome to your physics buddy. In this session, we'll be talking about ideal gas. So we'll try to explain what is ideal gas. We'll try to explain what are the characteristics of an ideal gas, what makes it different from the other gases. And we'll also describe the ideal gas on the basis of atomicity. So in order to understand what ideal gas is, we need to understand what a gas is. So in order to understand gas, let us try to look at few properties of gas. A gas has no specific volume, neither shape. As we increase the pressure, volume decreases. Also, as we increase the temperature, volume increases. So in order to understand all these points, we have introduced ideal gas. So in order to understand ideal gas to a bit more extent, we need to understand the characteristics of ideal gas. So in this video, we'll dive deep into this ideal gas thing and understand what ideal gas is. Before going next into the video, there is one question for you guys. If you guys know that what type of gas is being used to fill up the balloons, just let me know in the comment section. So, ideal gas is something, or you can say a gas is something which doesn't have a definite volume and it expands as we fill it through a small space. Such that you can say, you can talk about a balloon. In balloon, when we keep on filling the gas, its size increases because it needs to occupy some volume. The amount of gas occupied with the gas may changes depending upon the volume of the container. You can also consider, or you can also relate it with the gas cylinder. As you can, as you guys know, that the walls of the gas cylinders are generally more thick in comparison to the other cylinders. Why? Why the gas walls of the cylinder is more thick? Because of the gas contained in this cylinder is at high pressure, and because of that high pressure, we see that the gas molecules hit the containers with a greater velocity, and this makes it a little bit more important to handle with care. Similarly, we can also understand ideal gas is something which has no volume or zero volume. But the main thing is that no gas exists with zero volume. So that's why we don't actually understand, we don't actually see any gas having zero volume. That's what make ideal gas. A gas with zero volume. So this is something which is not possible to exist in this particular universe. But yes, if the gas do have zero volume, it might have certain properties which makes it completely different from other real gases and help us to understand. The next thing we need to know is that gas is something which flows. Flows means that it is something which comes under the category of fluids. Fluids is something which always flows, or you can say the particles of these particular kind of matter always stays in motion. So gas can move steadily and continuously. For any instant, you can say oxygen gas can flow from tank and through a tube, just like this. So we know that the divers who swims, who dives into the oceans, they generally uses this water, this oxygen tank through which a pipe is connected, and because of this flowing nature of the gas, this oxygen reaches to the mouth of the diver. Now, what are the assumptions that makes ideal gas different from other real gases? That is something we need to understand. The first important assumption of our ideal gas is that it occupy no volume, whereas all the other gases do occupies volume. Second thing we can say that the force of interaction that might exist between the particles of the ideal gas is almost negligible. Like we can say that the ideal gas generally do not interact with any other particle, which makes it very difficult for a gas to behave like. Whereas in all the cases where there exists a real gas, the particles collide with each other, the particles interact with each other, they do apply force on each other, and because of that, the collision which exists between the particles is something we call inelastic. So for ideal gas, the collision between the particles is completely elastic. Now, what does it mean? What does completely elastic collision means? Completely elastic collision means that there is no loss of energy during the collision. This is something which is very important, no loss in energy. But in real life, when gas interacts with each other, they do show energy losses. So again, this makes ideal gas completely different from real gases. Now, the most important thing is here that because of elastic collision, there is no change in shape of the molecule. So whatever shape initially the particle has, after the collision, it has the same shape. Also, the shape of the molecule is considered to be perfectly sphere. So that what make ideal gas different from other. Next thing we have to understand here is intermolecular distances. Generally, a container contains a gas, has gaseous particles placed in such a way that the distance between the gaseous molecules in comparison to the radius of the molecule is very huge. But in case of ideal gas, the molecule is supposed to be little closer, which makes that the intermolecular space is a little less, which increases the volume. And here I should say it increases the volume, this behavior. And here I would say as the particles are more closer to each other, their volume decreases. Now we are good to understand that what is gas. We are we know what are the characteristics of gases as well as what are the characteristics of ideal gas. And if we talk about what are the examples of ideal gas, we can say that no thing like ideal gas exists. There is nothing like ideal gas that exists. Now, if there is nothing like ideal gas exists, why we actually study it? We actually study ideal gas in order to understand that how can we make a real gas to behave like an ideal gas. We do make real gas behave like an ideal gas. Like if I talk about the real gas, all the examples you know, like O2, H2, N2, SO2, they all are real gases. But under certain conditions, these gases do behave like ideal gas. In order to understand these conditions, we need to understand the kinetic theory of gases, and that is something we are going to learn in the next video. Thank you guys. See you in the next video.